Hello. Well, finally,
Hello. Yes, we can do this. We nailed it.
we nailed it, and what an exciting day, right?
Yeah, yeah,
I
yeah.
mean, we've been waiting for years for this, and finally the day has arrived. So,
I can imagine. It must be, how do you feel? I mean, you are part of the mission, you know? So how long have you been working on this? It must be like 6 years or something, no?
well, 3 years ago, I joined the landing site selection workshops to choose where we're going to land. So
Hmm.
this was 2017, and since then, I've been waiting for this day. I was supposed to be in Cape Canaveral right now.
I know.
I
I'm
got
sorry about that.
I got an invitation to
Uh,
see the launch in person, and because of the
yeah.
virus, everything was canceled. So, well, we'll see it from home.
I know. Like the rest of us.
Yeah, not the same, but well,
Not the same, not the
it's
same.
but
But
very exciting.
so
And
how? Yeah, yeah, yeah. So you've been working on this for 3 years, and tell us more about like, okay, what's the selection process? So NASA invites like academics from many different institutions, or how does it go?
well, I received an invitation when I was in the last year of my PhD to apply to be able to present in the landing site. So I applied for that. I sent them the presentation that I was gonna do, and it was
Mm-hmm.
accepted. They liked it. So I went to California, to Pasadena, and I
Uh-huh.
presented Holden Crater, which was my favorite landing site for Mars 2020. And
Why,
and
why, why, why is that your favorite landing site?
well, I work with Mars analogs, so places
Mm,
on Earth that are very similar to Mars. And I've been studying for the last years an analog that is in the mountains in Tibet,
mm,
which is like a dry lake, a huge dry lake. And
mm-hmm,
this site on Mars, Holden Crater, was also a dry lake. And I thought that
mm,
the similarities were amazing. Holden Crater is a fantastic site to check
mm-hmm,
for biosignatures. It was also
mm,
proposed for the Curiosity rover back in
mm,
2012. So
mm-hmm,
that was the site that I chose, and it was a perfect location to see whether
mm,
life was there. The only problem, and that is why it was not selected, is because in the center of the crater there is like a mountain because of the impact
mm,
of the asteroid. So it was not
mm,
very safe to land there. And of course, NASA didn't want to spend billions of dollars in a mission, and then the landing was not very safe. So it was disqualified because of that. But still, I have faith that eventually one day we'll go to Holden Crater and
mm.
and see.
And what's the big difference between the Holden crater and the Jezero crater?
So Jezero Crater, they are not too far away, but it's a river delta. And this is
Mm,
interesting because a lot of river channels in the time where there was water on Mars transported sediments all over the crater, forming this delta, and created the
mm,
lake. So basically, you have sediments for all over the area, just just there.
mm,
So we see that water carried a lot of clay minerals from all the surrounding area, and you know microbial life could perfectly, all the requirements for microbial life were there. So it's also a very interesting area. And I tell you, when we were in the landing site workshops, it was extremely difficult to choose one site, especially in the
mm,
last landing site workshops. We had 10 landing sites, and all of them were amazing. So it was really hard
mm,
to just choose one. But anyway, Jezero made it to the final, and I have faith that we will find something. We will find something that will tell us,
mm.
life was there at that time. Water was there for a few billion years, so a few million years.
Really?
So yeah, the conditions for life were there, and hopefully,
Were there?
yeah.
Okay, water was there. Were there humans there? Ah, that's so such a suspense, you
Well,
know.
both Jezero crater and Holden crater are in the equator, where the temperatures
Mm,
are also much nicer, or at least how we understand for life. Like temperatures
yeah.
are warmer, that in the poles, and so there is no ice also on the surface, so the rover that is not slippery for the rover.
Yeah.
So hopefully everything is gonna be okay, and we're gonna see hopefully signs of remains of life.
So far the selection is based on the analysis of satellite images, correct? Because like if
Yeah,
it's through
yeah,
optical or infrared or whichever, right? And
yes.
of course, like sending it there, sending a rover there and sending humans there is totally different from just having satellite images, right? But how many percent, like how much discovery can you, from the satellite images, is it like how much do you know about Mars already so far?
So from the satellites, we can know about the mineralogy, but only on the
Mm.
surface, right? So
Yeah,
everything
yeah,
that is in the surface, we don't know about anything that is in the subsurface. And that is why the rovers have robotic arms that are going to dig down the soil and take samples from inside, from the subsurface. So we can only
yeah.
know what we see in the surface, the mineralogy.
Yeah, that's true.
As part of the requirements for the landing site is that it's a relatively flat area, so there is going to be an easy landing. And Jezero crater had all the conditions for a landing site, so we'll see. And then the mission has a lot of new technology that is not going to only improve future robotic exploration, but also human exploration for whenever that
Yeah.
happens. So
Yeah. I see there's a lot of like cameras, more microphone as well.
there are two
Um,
microphones, so we're going to be able to, for the first time, hear
here.
what happens on Mars. There is this little helicopter. It's like a little
Yeah,
box, like not too big.
ingenuity.
Is attached to the belly of the rover, and it's a completely independent mission. It has nothing to do with the mission of Perseverance rover, but it's going to be a demo flight to test how it is to fly in the very thin air of Mars. And
Yeah.
scientists are hoping that in the future this is going to help for humans on Mars. If you can fly helicopters, they can help you a lot about where you are, the mineralogy, and what is there, really.
Yeah. Okay. Sorry, somebody's knocking on my door. Oh, wow, that's interesting. And then it's not gonna land immediately, right? It's gonna launch tonight, and then the target date of landing is February.
It's February 18th
Yeah,
next year. So still a few months to
still a
wait,
while.
but uh, what can we do,
What would be
right?
the
This is the
first? What
closest.
would be the, and then it's sending samples back to Earth. It's planning to send samples back to Earth.
Well, it's going to collect a set of samples. So when
Mm-hmm.
I was presenting Holding Crater, the landing
Mm-hmm.
site, I had to prepare a traverse for the rover. So from the moment it lands, where is it going to go? And it had to choose. It had to choose sites that were scientifically or astrobiologically very important, to search for
Mm.
life. So in theory, it's going to collect all these samples, and another mission in a couple of years is going to go
Mm-hmm.
and pick them up and bring them back to Earth. So,
Which
I
is
mean,
like
this,
Marco said, the samples will be back on Earth in 2031, right?
well, the mission is not approved yet, so the dates are not official. I was, my understanding is that at least it's going to take 5 years for the samples to
Yeah.
be back. But you know, like if we can have real samples here on Earth that we can analyze in the laboratory, that's going to make a huge difference, right? This is not the same a rover and you receive data than actually having a rock with you where you can do analysis. You can check for any biosignature or any mineral that is called a biomineral that was formed by the presence of life.
Hmm.
So
So let's say
that's a,
you all find something. What's next? Like from microbiome or whatever, what are you going to do with it? And of course, you're going to analyze it, and then are you going to try to recreate it here, or what's next on the astrobiology front if you find something?
Well, that's the big question, right? Imagine we find life on Mars. It will not only mean that there is life on Mars, but then that we're definitely not alone in the universe. There are hundreds of planets that we've been discovering in the past years that are called second Earths, or that they live relatively not too close, not too far from a central star. So they are habitable planets. So if we find life on Mars, I think that will mean that definitely life is everywhere in the universe. And that would change history, at least for people that are study science. It would be like a turning point in history.
For sure. Ooh, I get the
Yeah.
chills.
Yes.
Maybe Elon and SpaceX will, get there first and actually bring the samples back.
That's
Probably.
gonna take at least a decade, but but this mission, Mars 2020, is the best mission we've ever sent to Mars. It has new technology, a lot of new instruments that are really gonna help to know whether life was ever present on Mars, really. So
Yeah. And
this is,
what are you personally excited about? Are you going to be involved in the post research once it's done? And then is there a part of a panel, and are you going to meet regularly to analyze the data? Is it going to be citizen science, or what's going to happen with the data from the Perseverance rover once it reaches there?
well, there's going to be a lot of action in space exploration for the next years, right? Because of this rover, and in general, because there is a lot of interest in space exploration right now. I hope I can be one of the first people to actually analyze those rocks that come from Mars. They can go directly to my office. That would be really nice. But for sure, I'm going to be involved. I work on Mars analogs, so we study these extreme places on Earth that look like Mars. And for that, we need to study what's going on Mars at the same time. So we normally study Mars through the orbiters that are there, but of course, the more data we have from the rovers is a closer view, right? So the more information we have, the better we can understand what happened there. So yeah, definitely I'm going to be involved, and who knows how, maybe in 5 years I can be, analyzing these rocks. It would be extremely exciting.
Wow. But for now, it will be streaming the data, from
Yeah, so the rover is going to send the data to an orbiter, and the orbiter is going to send the data back to Earth. And normally, NASA makes all this data available to the public. Not all of it, but it's available to the public, so anyone can really, join in, and as well as a lot of pictures. Yeah, so all these pictures are, in fact, the NASA website almost daily will post pictures about the surface of Mars, taken by orbiters or by the rovers. So a lot of it is public, but yeah.
Have you been in touch with your friends at JPL or at the university, your colleagues that are on the same project as you are?
Yeah,
on this?
I actually, a good friend of mine is the deputy director of the Mars 2020 mission. He likes to call himself the King of Mars 2020. and
He is practically.
and he couldn't even go to the launch either. So it's been devastating in a way, because it's been many years of work, and we've been waiting years for this day, and there's nothing we can do, right? Especially in Florida, it's really, really bad with the virus, so nobody's allowed in the launch. So and we couldn't cancel the launch, because then we have to wait 2 years until the Earth and Mars are close together.
Even now, it's already 30th of July.
Even now, we're kind of a bit late, but anyway, the mission is ready, so it's going, and it's such a pity that is people all over the world, excited about this, and we cannot be there. But anyway, maybe for the launch, for the landing, when it arrives to Mars.
Well, yeah, surely they'll be in February, right? Although I don't know what's going to be the situation with the Corona thing, but we'll still be here,
Let's hope.
hopefully.
Let's hope
Um,
so.
and you mentioned a few times how the landscape, there's few places in Mars that are very similar to Earth. And so which is Tibet, and then
Well, so I study Mars analogs, so places on Earth that not just look like Mars, because how you look at them doesn't really tell you much, but also it's more the geological history and what happened there. So normally these are extreme places, like really, really high altitude or really dry deserts or extreme conditions in general. So the one I've been studying is these mountains in Tibet, but I also been a bit involved in studies in other extreme environments, like in Australia or New Zealand or in Spain. Next year, we're planning to study the Atacama Desert in Chile, which is also one of the best Mars analogs. It's the driest place on Earth. It rains once every 10 years. So the organisms that you find there are extreme in the sense that they don't use water to survive, or they use very, very little amount of water to survive. So all these organisms, studying the survival strategies of these organisms, really tell us what we could find on Mars. So
I wonder if there's any similar landscape here in Indonesia, because desert, we don't really have desert, but the eastern Indonesia, it can be very dry during the dry season, of course, and we do have this one island that's pretty dry in terms of it has the lowest rainfall rate throughout the whole year. And you can see the Milky Way very clear from that island. And they have a very interesting geological features as well, like the Chinese canyon. That's, so
well, maybe. I mean, in all these Mars analogs, of course, when you are there, it really looks like you are on Mars. There is no trees, absolutely nothing. No people living there, not even insects live there, because it's so extreme. The conditions are like the temperature from day to night, and the relative humidity and everything is very, very extreme. But I've never heard of a Mars analog in Indonesia, but I would love to go there and analyze it if it's there.
That's why I was like, I wonder. I mean, we are 17,000 islands. Of course, we're tropical. We're in the equator. We have high rainy season, mostly cloudy, but there are some dry spots here, and during the dry seasons, it's really dry. So
Antarctica, for example, is another Mars analog, is more an analog of the North Pole of Mars. So, but it's a little bit harder to get there. But yeah, a few years ago, I was studying Antarctica as a Mars analog. And I think one thing that people that study Mars analogs tend to say is, my analog is the best. But, actually there is the perfect analog, because it depends what we want to study on Mars. So if we're studying extremophiles, if we're studying geology or the temperature, it really depends. So the whole information about all of the analogs is what really makes you understand what is, Mars and what it would be to live on Mars or find life on Mars.
People keep on asking, what if there's no signs of life on Mars? Well, that's a bummer.
Well,
that's a downer.
So I always tell people when they ask me, like, what if we don't find anything? And it's like, I always try to think it the other way. Like, imagine you are an alien and you are landing on Earth, and you are landing in the middle of nowhere, and you're trying to find life. And let's say you are in a desert and you don't find life. That doesn't mean there is no life in the planet, right? It's just in that location there is no life. So I think if we don't find any evidence of anything, we'll just keep looking. We'll go to another location and just try to keep understanding what happened on Mars. Because, the conditions on Mars about 3 billion years were very similar to Earth. Liquid water, nice atmosphere, nice temperature. So all the conditions were there. So we're hoping to find something, at least not life right now, but at least some remains of life in the past. That would be awesome. Yeah.
And of course it would change everything, but why is it so important for us to seek for the answers? Some people are just like, let it be.
Well, I think it's in our DNA. You know, we are explorers. You have plenty of examples and evidence throughout history of people that wanted to explore the Americas, wanted to explore the ocean, the poles, right? So the next step is space, definitely. Not space, just space, but Mars. Like in the 60s and 70s was the moon, and now it's definitely Mars. Mars is the next step, and you know, I also receive a lot of questions of people like, why are we doing this now? You know, like, do we really need to do
Is it
this?
the
But
right time?
imagine how many people have jobs thanks to this. Like so many people are working on science and on, you know, engineers building the rovers and the rockets, and you know, this is giving jobs to a lot of people, and it's the excitement. It's like the whole humanity is together for this. Like in a few hours when we watch the launch, the whole world is going to be tuned and is going to watch
Yeah.
the launch. So
Which is also interesting because, you know, a lot of my friends are in trading or property. They've been
yes,
hurt very bad during this pandemic, you know. And I'm like, that's why you should do space. Doesn't seem like, well, of course there's some
we're done
impact,
with
of
Earth.
course, you know, but of course there's some impact. But it seems like it was just funny. And one of my vendors are like, there's still launches during this event, you know, this pandemic. I'm like, oh yeah, we've had like
There are,
a
because
few
this is also
already, you
what
know.
people ask. Like the launch has
It's
to
like,
be the exact day. We cannot postpone it 6 months, because then it would take
yeah,
double or triple the time. So the
yeah,
launch
and there'll
has
be
to
more
be
money.
more money and more time, and it
Yeah,
wouldn't make any sense. Like,
yeah,
so
yeah,
this is
yeah.
the time. If we miss this opportunity, you know, we have to wait. And you know, the mission is ready. In the case of the NASA mission, for example, the ExoMars mission from the European Space Agency and the Russian Roscosmos has missed the deadline, so they have to wait for 2 years, 2 more years.
Ah,
But you know,
that's a pain.
of course, this costs millions of dollars. You don't want to just risk. Everything has to be really, like, if you send it, it's because you're sure
Yeah,
it's going to be successful as in the best of your knowledge, right?
yeah, yeah. I think Perseverance has been going on for a while. That it's good to go. Yeah. Was a bit surprised with the Hope mission because suddenly it's like, what? They're sending it on the 15th? Wow, they've been really quiet about that. But what other Mars project are you involved with?
This is the only mission that I've been involved with. I did the landing site for the rover, and this took a few years, and then I included all of this in my PhD. So I did, one of the chapters of my PhD was about the Mars 2020 mission, and then since then I've been involved in a way or another with this mission. It's definitely the most exciting thing that we're sending to Mars ever. So I'm very excited, and I really hope everything goes well during the
It has
launch.
to.
It
It
has
has
to,
to.
right? I
It
mean,
has to.
in a way, you know, the Perseverance rovers is a copy of the Curiosity rover that went to Mars in 2012. It's an exact copy with a few improvements. So NASA was like, you know, this one worked, so now let's take the same
Improve
idea
it.
and improve it. So I think it's pretty safe that it's gonna be all right. Yes.
But what do you say about sending human to Mars?
Well,
Because somebody asked me the other day, like, will we get to Mars by 2030? And I'm like, well, you don't know. Maybe China will show up there next month. But
well,
what do you say about that?
that's a completely different thing, right? It's not the same sending a rover that is a small thing. That sending humans, you need a proper place for them to live and survive for a few months, food and water and bathroom facilities, and so it's a completely different type of mission. But I'm hoping that in the next 10 years, and this mission, Mars 2020, is really going to be revolutionary in terms of new technology that, for example, the helicopter that we're going to be able to use for the future of human exploration on Mars.
Yeah, because
So,
how far does the rover the range of the rover? I
so
think one
Robert,
of the rover got stuck I remember one of the rovers, I don't know whether it's Curiosity or what, I think it
Yeah, they
got
get
stuck
stuck
in a,
many times.
yeah. That's
In a,
crazy.
they get stuck many times, but so the rovers travel very, very slow. So they only cover a range of about 20 kilometers, which is not
Yeah.
a lot. That's why it's very, very important to choose the right landing site. And not just that, but to choose the right traverse for the rover to go, because you
Yeah.
just have a very limited amount of time and space that the rover is going to be analyzing. So, but you know, if it's in the right place, in the case of Jezero crater, if it's in, you know, in this delta and it's going to start analyzing all these samples that had biosignatures, then who knows? And I know that the scientists might allow the rover to stop. And if they find something interesting, just stop there, analyze it, and then continue. So it's really hard to say how long is it going to be in each site, but the rover is designed to last for a couple of Earth years, which is one Martian year. So,
So, so they say, can we really grow potatoes on Mars? And does the rover works with solar energy?
so about the potatoes, I think it should be fine. According to the movie The Martian, everything he did, in my opinion, it should be, you know, properly.
Directly on the Mars soil with the space
But
farming
of course covered, not exposed, because there is a very thin atmosphere,
greenhouse.
so you are exposed to all this cosmic radiation. So it will definitely kill the potatoes if you are outside. But if you are in some sort of a greenhouse covered and you can have the right conditions, I don't see why not. But I'm really not an expert in this topic. And then regarding how the rover is going to get the electricity, it's going to get heat from the natural decay of plutonium 238 that is going to, it's going to naturally decay and it's going to generate electricity. So it has solar panels, and so it's a completely independent rover. So as long as there is no sandstorm that is going to cover the solar panels or anything, it should work fine.
Wow. Okay.
Yes.
So, but the radiation on Mars, can you share that?
Is prepared for that. It's totally prepared for that. Not for humans, of course, but the rovers are protected for that. And all the instruments are protected against that radiation, the extreme levels of radiation. So everything should work.
Wow. So, was Mars always on your list, or did it only came after? Has it always been like, some people are like, I want to work on Mars from the very start, but I see like throughout your whole study and career, there's many different paths, and suddenly, why are you so fascinated with it?
For me, I think I was very lucky. Since I was a child, I knew that I wanted to find life on Mars. So it's been all my life about just Mars. And, I just went for it. And I had moments where I would receive emails from people, or just universities would tell me you are not good enough, or you can do this, or your idea is not feasible, or whatever. But I just was very persistent about, definitely I have to do this. And Mars is the closest and the most interesting place, in my opinion, in the solar system if we want to find life on Mars. So I've been for many years studying Mars analogs, and studying how can we study the possibility of life on Earth, on Mars from Earth. So
Understanding.
as
What did you
part of
say
my
again?
job
Understanding.
is very nice, because as part of my job I had to travel to all these extreme places on Earth. So we have very extreme expeditions, and we are planning a few for next year in Atacama, in Iceland. So it's a very exciting job. But then we have a lot of work in the laboratories as well to analyze all these samples and see what happened there.
So when you
yeah,
analyze the samples, you're analyzing the geological and the minerals and the properties of the rocks.
We try to analyze as much as we can. So the geology, the elements, the mineralogy of the sample, And also we try to see if there is any biomarker, anything that is related to life. And if there is, we try to extract the DNA and see what type of life is that. And then we analyze the conditions, like if this type of life was able to survive under these conditions, these conditions are pretty similar to Mars. So maybe we can find the same type of organisms on Mars. So it's all about comparing and, trying to guess. If we find this that is very similar to Mars, we may find the same in there. But, until we cannot be on Mars as humans, it's challenging because, the rovers don't give you a full picture of what is happening on Mars. They just focus on a very specific site. But anyway, it's still very exciting.
Well, of course, it's just the thought of like you're launching something from planet Earth and it landed on another planet. That in itself is already remarkable, right? I mean, it's not a missile. It hits, but it's intercontinental. But like this is out of the solar system, it's out of the planet, and it reaches another planet. That's very remarkable.
It is.
I can't even aim to the. Sometimes I can't even aim the bin. So.
And that's why I think that when people ask, why do we need this now? Like everyone is excited about this. Whenever you bring the topic of maybe we're going to find life on Mars or, we're traveling to Mars, everyone is excited. It's like, oh my God, what if we find something, like there is a common interest in anyone, and doesn't matter what you do in your life. There is people, I find that everyone is interested in this. So, I mean, the mission I've been involved with is the NASA mission, but, any mission like the United Arab Emirates or the Chinese or any mission is, with the same purpose. Like, let's find whether life was there on Mars before. And
do they share the data?
I mean, the Chinese Space Agency is quite... I think if you are not a Chinese citizen, you cannot be part of the space agency. So then in that case, you don't know what is happening. But to be honest, I'm not sure. I think the United Arab Emirates is pretty open, and they are looking for a lot of scientists from all over the world to join the science team. But I know the Indian Space Agency is doing quite well as well. And I don't know, I think, like in the 60s, there was a space race to see who was the first to reach the moon. I find that with Mars, it's more like an international effort, like the International Space Station. It's like something that is for the whole world. And we all together are going to try to find life on Mars, which is beautiful. It's not like your nationality doesn't allow you to work for this space agency or, so... Hopefully we will find something and the whole world will be excited about that, not just because it's a NASA mission or it's a Chinese mission. So we'll see. We just have to wait a little bit and see what happens.
Can we extract fuel from Mars, at least if we don't find life there? Resources.
That's actually a very good question. And
yes, baby.
I know there are a lot of studies about extracting fuel from asteroids. So if we want to do interstellar space travel, we want to travel to, of course, this is a futuristic vision, but if we want to travel very, very far in space, we need fuel, right? So the idea is to be stopping in asteroids, extracting all the fuel and all the resources that we can get, and then continue, right? So on Mars, yes, I believe we can extract fuel, and there is a lot of resources that we could get from there. But you have to think for what. So it will be to create a Mars colony, or to create like a, it depends for what do you want. But yes, I do believe that Mars is a rich planet in terms of resources. So.
What's the highest mineral content from Mars that would be useful for extraction?
Well, the thing is that we don't know what is in the subsurface. So what we know only is in the surface, except for those places where rovers have been that they can dig samples from the subsurface, but there is a huge content of iron in the surface, and that's why it
Of
has
course,
this
because it's red.
reddish color. So
Has inside,
yes,
because inside is drilling the soil as well, right? I think inside, or I
drilling
think it's just
drilling the soil, or in the future we're studying whether we could go inside lava tubes. So lava created these channels under the surface, which is a possible good habitable place, not just for humans but for organisms, because you are protected from the outside environment, and maybe liquid water is there. So
and that's where you find the Martian living
that's
underneath,
this is where they are hiding. So
right? In those channels down below. Oh
we'll
God.
see.
So for future Martians or for students there, I know that there is a lot of interest by the youth, by students in high school now. My cat decided to join my IGTV. And so what would you say to them if they are really passionate about Mars, if they are what
For
should they
students,
study, and for students, aspiring astronauts to go to Mars, what would be your message to them?
so I get this question a lot. Like a lot of people every day send me emails or texts about how can we do what you're doing, or how can I become an astrobiologist, or so. Well, I think that the first thing that I always tell is you have to be really passionate about it, right? Like you really want to do that, and then it's about finding your way. I don't think there is a bachelor degree that you can do in astrobiology as such. At least there was not when I started, but you can start studying biology, geology, astronomy, astrophysics, engineering, and then as a master's degree or a PhD, then you focus a little bit more in astrobiology or in planetary science in general. And then as a PhD, you definitely can do a PhD in astrobiology. But I do recommend having some knowledge in geology, planetary science, astrophysics, and biology.
Okay.
Yeah.
Would you recommend any? You went to school in many different places.
I went to school in many different places. So I studied my bachelor degree in Sweden, and then in Germany, and did 3 master's degree in Spain, and then in London, and then my PhD in Hong Kong. So, and I decided to do my PhD in Hong Kong because I was, close from these mountains in Tibet. That is the place that I study. But, a lot of universities in the US are doing astrobiology programs. So, one way or another, just
That's a long time for you studying. Was it always back to back?
it's been a,
Master
it's been a, it's been a long time, but I enjoyed it really a lot. I was really, really enjoying what I was doing, and it was a bit challenging. Like, some of the topics in astrophysics we don't really know. It's all hypothesis, but but I was so passionate about it that I did it. So
But I think that's the whole point. That's the entire point of these space exploration jobs. The entire job is the entire role. You just have to keep on learning. You have to study all the time, and you have to keep on studying all these new data, and still look. Yeah, right. It's like it's just
it
very
is,
academia.
and it
It's
is, and
research.
it's constantly changing, and not just that. Is astrobiology is a really broad term, so you have to know where the rover is landing. So you have to know geology, you have to know how the rover is landing, you have to know about engineering, astrophysics, the radiation levels. Then you have to know about biology if you're looking for life. So any of those topics is really going to help a lot if you want to become an astrobiologist. And yes, I think in general, scientists, we have to read a lot. Like every day there are new articles published, and things that we believed in the past now is proven that it's something different. So there's a lot of reading. But again, if you really enjoy that, you just don't mind doing it.
Yeah, of
So
course, because you always want to know, right? And
just
so
want to know.
during the pandemic, is there any conferences like do you go to annually, or well now it'll all be online, right? But what are the
So
biggest or the annual astrobiology conferences that particularly on Mars specifically?
um, so there is a just it's called this Mars conference that I went last summer, and there is an astrobiology science conference. It's called ApSciCon, which is a very very famous conference from NASA. It's every 2 years, and if you want to do astrobiology, that's the conference you want to go to. Not just hear what people are doing, but to meet people in the field.
Mm.
And so I think there are a lot of conferences about Mars and space, and I would suggest just choose the ones that are big enough. I also, because I live in Hong Kong, I do the Australasia Astrobiology Conference, which is Hong Kong, Japan, Australia, New Zealand, all this
Yeah.
area. And it's really good. It's kind of a small conference, but in the end you end up knowing everyone in the area, what they are doing. So it's it's a nice way of knowing what people are working with.
Yeah, regional, right? Because mostly
Yes,
it's US
regional.
centric or Europe, but we need to
Yeah,
rely more on
yeah,
the regional. Wow.
yeah.
How's the, I don't know, I've never heard about space in Hong Kong. How's the scene in Hong Kong for the space industry? Because Singapore is definitely growing with our friends there, Jonathan and Lynette, building the SSTL, formerly SSTA, Space and Technology Association, but I've never heard Hong Kong space scene. How's the space scene in Hong Kong?
Not too big, no. So
But that's where all the
we're
money is.
well, that's one of the positive things, that there was money here. So if you're going to join all these international conferences, or if you have to do all these field expeditions to Tibet or to Antarctica, of course you need a funding source to pay for all of this, right? So Hong Kong has the money, but it's not really there is a group of people working on astrobiology and Mars, but is really not too big. Macau also has a astrobiology group, but
Really?
again, it's like 5 or 6 people. So in a way, it's nice because everyone knows each other, everyone knows what each other is doing. And I guess in the US, it will be like you're just one more of millions of people doing the same. But I mean, not the same, but working on astrobiology. But it's also an important aspect to be here. In Hong Kong, it's also a really nice area to explore these extreme environments. We're kind of close to everything, so it's been
Yeah.
nice. Yeah.
So your next plan when travel is permitted, I suppose, which is Iceland and what was the other one you said?
Oh, the Atacama Desert in Chile.
Atacama, exactly. But these are scholars only, I suppose. I assume I mean, it's not just regular person that wants to sign up and they can go on this expedition, or is it a
Uh,
public analog trip?
no, in my case, it's a private. It's through a group of people that really want to do that Mars analog. You need special permits to get there. Now, I don't know. I think some parts of these areas are open, are touristic open to the public, so anyone can go and see them. But it's better to have like a permit that allows you to do a proper expedition, because then you can bring samples back and you can report it as a scientific expedition. But in some of these areas, people can just go. Not in my site in Tibet. This part is extremely difficult for non-Chinese citizens, which is my case.
Mm-hmm.
But yeah, some of these places are open. I mean, some of them are a bit challenging to get there, but yeah,
So
so
in
anyone
your
can
case,
go.
in the Tibet permit, how long did it take and how much did it cost?
The cost was not important. I think it was how much did it take, and then once I was there, still even with the permit, I was not allowed to go in because this site in Tibet is a military controlled area in between China and Tibet. So it's not an easy place for foreigners. So I've been there a couple of times, and sometimes I've been told I have to leave in the next 24 hours. So we would have to do all the science and all the expedition really quick in just the next 24 hours. And then I would be waiting somewhere in a small town, and then my team would be doing the science for me, so it's not the easiest place. But I think, for example, in Iceland, it's pretty easy. You just need to apply 3 months in advance. I'm not quite sure if there is any price to that, but I don't believe it's any difficult to get there. And if you have a proper scientific proposal that this is what we want to do, then it should be fine. Yeah.
And who provides funding for these expeditions?
Well, in my case, it's been a university where I work. Yeah.
Okay.
Or sometimes, so many times conferences have also an expedition after the conference. If we do like astrobiology conference, there is always an expedition, and then there is scholarships that you can apply, and then they give you the money to go for free to the expedition. And I've done that a few times. So yeah, there is always somewhere where you can apply, or some money available, especially for students. So if people are studying a master's degree or a PhD, there is a lot of opportunities for early career scientists. So if I were one of them, I would take advantage of that, because once you become a proper researcher, is not that easy. Yeah.
Okay. And is the Explorers Club celebrating this day?
Well, the Explorers Club, I'm pretty sure. So we have a few members of the Explorers, quite a lot of members of the Explorers Club that are, astronauts of the Apollo mission, and having jobs related to space. So I'm pretty sure everyone is going to be tuning in to the TV later on to see the launch. Yeah.
Wow. It must be thrilling for everybody that's been working on the project for many, many years. Just finally come to the day.
It's a lot of mixed feelings, right? I find that I've been 3 years waiting for this day, and finally the day has arrived. It's just in a way you cannot believe it, and I've been really nervous the whole day. Like, I just hope it goes well. I'm pretty sure it's gonna go well, but you just have this excitement of
Yeah. Just hope
after all
they're
these
not
years.
gonna scrap, because it's not like any other it's not like any other launch that it's like, okay, we'll scrub and then we'll do it in the next few days, right? Because we have a window and you hope that it has to be now. So
It has to be
there's
now,
a lot of suspense. Yeah, it has to be now. A lot of suspense. But Mars is pretty busy this month.
Mars is busy. There's a lot of things going to Mars, and it's going to be super exciting in the next 5-10 years. Imagine all the data that these rovers are going to send back to Earth. It's going to give a lot of people a lot of work to do. So.
And that's where I'm also trying to promote this, right? I mean, Indonesian data science, or data scientist to how can we contribute. If the data is public, then we can probably do a citizen science project to assist researchers like yourself, or experts, or maybe NASA or the other agencies that have the Mars. It may not be the primary data, it can be secondary data, but you need a lot of help in analyzing all that data to compress it, right, and to have answers in a few years. So that's the part that I think we can contribute, because we definitely won't be able to contribute in the rockets, nor the rover.
Well, there
Yeah.
is a lot to do. Like as soon as the rover arrives and it starts sending data back, there is a lot to do. So scientists in Indonesia can start really looking at the data and start to study what happened there and see whether we all together can find whether life happened on Mars or
Yeah.
not. So
Yeah.
you just don't need to be building a rocket, but there is a lot of other things that you can do, and I'm pretty sure Indonesia is gonna be involved in this.
Yeah,
Yes,
I think we have more than enough people here, and
yes,
to promote science and STEM development here too.
mm.
So yeah, I think that's that's that covers majority of the Perseverance launch for today in terms of the crater. And thank you for your time. It's both of us moved house at the same time, huh? So my
Yes.
house is still I'm still like settling down as well. But I thank you so much for squeezing
Thanks to
in
you.
a few
Thanks to you,
minutes
and
and
for everyone listening, the launch is in 2 hours and a half.
I
Yeah,
think
two
the
hours and a half.
pre-launch events, yeah, I think the pre-launch events have started. I see it at like 4 o'clock, but it's like pre-conferences, right? It should be,
Yeah, so
but
everyone just go to the NASA TV and let's all watch the the launch together. So
yeah, and if you are at NASA Social, I'm sure it's going to be streaming online as well, and everybody can join the watch party on Facebook. I know that you are there. I saw
yes,
you there too. So,
yes.
congratulations to you. Um,
Thank you,
I hope the
and
launch will be a success.
yes, thank you very much.
Yeah,
And yeah,
thank you.
let's talk after the
Yeah.
launch and
Yes,
congratulate each other for
keep
this.
in touch.
Okay, bye
Okay.
bye.
Thank you, Angelica, and thanks everybody that tuned in. I'll edit the IGTV and post it for those of you who missed it. And we'll meet again with Angelica. Okay, bye. Have a good day.